shout out Zoom people. Thank you very much. Okay, can you see it now? Somebody say yes, please.
Yes.
Hot dang. Awesome. Thank you very much. All right, go team. So we basically just have a chunk to the fourth power all over just some chunk to the second power. Now, on your guys' homework, sometimes if I got a web assignment question, I wouldn't just give you the answer. I'd just tell you the rule you're supposed to use. Can somebody tell me what exponent rule we're supposed to be using for this critter? Subtraction rule, there we go. So this dude is just going to become chunk to the 4 minus 2, right? So if you have a like base in the top of your fraction and the bottom of your fraction, what you're going to do with their exponents, as long as everything's strung together with multiplication, you can go ahead and just do top exponent minus bottom exponent. And here, that's just going to go ahead and give us chunk to the second power, also known as chunk squared. So chunk squared is going to be equal to a squared plus p cubed squared. So we've got this going on for us. Now, when we're squaring a term that's not a singular thing, right? Like 3 squared, you're just like, okay, fine, that's 9. You know, x, like x cubed, if I square that, okay, you multiply and that's going to be x to the 6. Those are really easy when they're just one-off things. Here, though, the trick is we have this plus sign separating them. That's your hint that this is not going to be a simple raise everybody to the exponent thing. I talked about that last week. I'm just reminding you right now. But basically, the idea here is you want to FOIL this thing, or do some facsimile of that whenever you have terms that are separated by addition or subtraction, you're raising it all to a power. So this is just going to end up being a squared plus p cubed times a squared plus p cubed. And then we go ahead and FOIL. So for first, we're going to get a squared times a squared. So that's going to be a to the 4th plus outer a squared times p cubed. Well, we can't do anything with that, so that's literally just a squared plus p cubed. Nothing we can do there. Plus inner a squared p cubed again. Again, nothing we can do there. We can't make a's combine with p's. We can't do anything with their exponents or anything like that, so we just leave it. And then we get last, p cubed times p cubed. We're going to go ahead and we're going to get p to the 6th. And then just another little thing, we do have some like terms in here. Now, when I refer to like terms, important thing to know, that means all the variables are the same and all the powers on all those variables are the same. So we have a squared p cubed, a squared p cubed. Okay, you have a and p, a is raised to the 2nd, p is raised to the cube. Because that all lines up, then I can combine them with addition. When I do so, a to the 4th I leave, I'm going to have 2 of these critters. And this right here is your final answer. Questions about the process? Or the answer? How many of y'all feel like you did that right on the written assignment? Right? Show of hands. Okay, decent amount, decent amount. We also have a decent amount that don't feel so confident. And that's fine. That's fine. That is what this is for. That's what, this time in class is for. That's what my office hours is for. That's what the written assignments are for. Is I'm just trying to tune you into a finely tuned algebra dominating machine come exam time. Which, by the way, I just want to remind everybody, not this Wednesday and Thursday. I don't even think next Wednesday and Thursday, but the week after that. So not next week. But I think the week after that, we have our first exam. So FYI, seeing your eyes light up a little bit. See, this is a great thing about in-person is I can actually see your eyeballs now. This is great. Okay, and I don't think I see anybody lighting up the Zoom chat anymore. Not that I can actually see it. Yep, don't know what's up with that. Nice. Okay. Nobody's yelling at me. So, okay. Okay, so what is today? Today is going to be about factoring. Okay, so can somebody in here, and you may or may not be able to do this, but if my grandma walked up to you on the street and said, young man or lady, can you tell me what factoring is? All right, if my 84 Hungarian grandmother walked up to you and asked you that, what generic, plain English definition are you giving her? I haven't talked about factoring, so I just want to know if anybody actually could do that. If not, that's fine. Nobody wants to try? All right. Factoring is basically just the process of breaking up multiplication. That's all it really is. Breaking up, and I want to put slash undoing. And the super simple demonstration of that is if you have 2 plus 2x, okay? Simple, super simple couple terms here, okay? They're added together, but there's some multiplication going on that we can rip out, okay? They have a common factor, and that factor is 2. They both have a 2 in them. So what we can do is we can rip that out, and we can say this is equal to 2 times 1 plus 1x, but I'm just going to write x. So that's the idea behind factoring, is what do they have in common that they've both been multiplied by at some point in their lives that we can rip out and have as a component multiplied onto them. So the 2 was in common, and if you just want to quickly see that, 2 times 1, we get 2, 2 times x plus 2x. Okay, yeah, we can go forwards and backwards with this. Nice. Okay, make it a bit trickier. This happens with variables as well. If I have something like, I don't know, 15x cubed plus 21x squared. Okay, now this one's a bit trickier. This one's a bit trickier, and the reason for that, is there's numbers and variables that are in common to both of them, but not everything. So, if I were looking at this 15x cubed, I'm noting that there's a 3, there's a 5, and there's 3 x's in here. Now, in 21x squared, we get 3. We don't get a 5, we get a 7. And this only has 2 x's. So the idea behind factoring is you can just eyeball a lot of times. You can just see, oh, those both had a 2 in them, rip the 2 out. Okay, that worked for the first one. With this one, yeah, you can just eyeball it, but it's safer to also know that the core principle is look at how much is in common and just factor it all out, split this all up, and then just take an inventory. You can do this. You don't have to do this. I'm just saying this is how it works under the hood. And basically, we see that there's a 3 in common, and they both have at least 2 x's. Okay, now, if it doesn't have a buddy, I can't rip it out, right? This x does not have a pair on the other term, so we're not going to rip that out. Actually, when we factor this, we're going to leave that there. That's exactly what I'm going to do. So 3x squared comes out. Now, think about what's left. You can look at your list and say, oh, I left a 5 and an x on the first term. Excuse me. So that's going to be 5x. Over here, I just left a 7. That's it. So all that's left is plus 7. Okay, do I expect you guys to do all your factoring problems this way? God, no. But is this a way you can do it, and is this a foolproof, more or less, way to do it? Yes, absolutely. You break down everything into, common factors and all that jazz, yeah, you're going to be fine. Going to be fine. Questions about this process as I adjust my helmet? There we go. Has this knob in the back. I can actually tighten it. I kind of feel my skull being squeezed a little bit. That's much more comfortable. Those of you zooming at home, you'll get to see it tomorrow. Okay, if we don't have any questions about this, I'm going to show just one more example. I'm going to go a bit faster with it. But same general principle. So let's say we have 64 x squared y plus 16 xy squared. That's actually pretty similar to one of your homework problems. And what they ask you to spot is they ask you to spot that there's a 16 in both of these, right? Because 16 times 4 makes 64. So there's a 16 in both of them. There's at least one x in both of them. The other term doesn't have 2, but it does have 1x. And then they both have at least one y. The one term only has 1, the other one has 2, but they both have at least 1. Okay, and then they ask you what's left. And we're going to get 4x plus 16 divided by 16, 1. I'm going to ignore it, and I'm just going to write y. And that's how you would factor that. Okay, you can just eyeball it if you feel comfortable with it. But I will let you guys know at least, there are some numbers that are going to get a lot bigger. I would not expect you to know, for example, if you got a problem, what's a color I can use that you know is weird? If I do 3,125 x squared plus 625, okay, I would not expect you guys to eyeball this and say, oh, there's a 625 in common there, and that's just 5x squared plus 1. Okay, I don't expect you guys to know off the top of your heads how to factor a big number like that. That's why I'm telling you guys, using either your calculator, your pencil and paper, or your brain, ideally something other than just your brain, go ahead, just start taking things out. Just start taking out 5 and then see what's left. Take out another 5, see what's left. If you spot that these both have a 25 in them to start off with, great. Rip that out, see what's left. You can always take out more. Now, I want to talk about, though, what does it mean to take out more? So actually, I might use this weird example. Okay, let's say one of you guys realizes that that thing is 5. And then if we take out 5, okay, you take out your calculator, you do 3,125 divided by 5, you get 625. And then x squared, make sure we don't forget that. And 625 divided by 5, we get 125. Okay. Somebody had a very good question about this over the weekend. What happens if you rip out more from like a square root or something, right? Because you guys were doing roots and radicals and all that fun stuff over the weekend with web assigned homework. This is basically the same concept. Instead of ripping things out of roots, you're ripping it straight out of terms that have, whole exponents. But it's the same kind of principle. What happens if we rip out more? So you basically just end up with, okay, 625 and 125. What's another number we can take out? We can take out another 5. Just keep ripping out 5s. So at that point, you're going to get 5 times 5 times, then what's going to be left? 125 x squared plus 25. Okay, now here's the trick. What do you do with these critters? What do you do with them? And the answer to that one is you multiply them. So you multiply them and you just go ahead and you get 25 times quantity. So when you're successfully ripping out terms, and usually you're only doing it a bunch of times when you're ripping out numbers, but you might do it with variables too. But what you do when you rip them all out, okay, it's factoring. We're undoing multiplication. That means we're working with multiplication. So we can just go ahead and use multiplication to slap those together, and then we just have our leftovers. Okay, questions about this process? Comments? Seriously, you guys are So quiet. You understand, like a whole bunch of you are freshmen, this is your first like college class, and it's also 8 a.m. and I don't know if you guys get up at 6 like I do to get your Cheerios in. Oh, hey, mask, nose. That's a thing. Yeah, no, 6 a.m. Cheerios. They are a good way to start. Okay. Okay, so I want to do something just a bit more complicated now. So there's a special rule, and it's so special I'm going to write it in red. Difference of perfect squares. Okay, and what the difference of two perfect squares rule is really getting at is if you see some critter that looks generically like something squared minus something squared, okay, you have that difference there. It's something squared minus something else squared. The way you can peel that apart is you're actually just going to get a plus b, a minus b. And just as like a super quick example, let's say I have 9 minus x squared. That basically peels apart. So it's always going to be the square root of the things you started off with, right? Notice I went from a squared to a to the 1 and b to the 1. So you're taking the square root as you do this. But you're basically just going to get 3 plus x and then 3 minus x. That's how that's going to end up falling apart. Now, if you're wondering how the heck this works, I actually want to show you the opposite. Let's FOIL it. So let's go ahead and FOIL these two terms. When we do that, we're going to get 9 plus, actually no, not right off the bat. We're going to get minus 3x plus 3x when you do the inner, and then last you're going to get minus x squared. So the reason this difference of two perfect squares is super neat is that these two terms in the middle here, they end up canceling. You have minus 3x and plus 3x. Those end up canceling out to make 0, and that's why we're left with good old 9 minus x squared. So you can go forwards and backwards with this if you're ever not sure. And that's a beautiful thing about all of your factoring problems. And I highly, highly encourage you, both on this homework and for any other problems that you're throwing in my class with factoring, if you're not sure whether you factor it right, just slap it all back together again. Just go ahead and multiply it all out and see if you get back to where you started. That's always a good thing that you can do. I'm doing it here to show that the rules work, but you can do it to show that your problem answers are actually right and actually appropriate for what you just tackled. Okay, questions about this? Okay, the other thing, we have 2 more rules, except now we're going to take the exponent up a notch. Okay, we had squares on these, now we're going to go up level, we're going to go up to cubes. So we have sum of cubes, and then we also have difference of cubes. Okay, now the sum of cubes, it is what it sounds like. You're basically just going to have a cubed plus b cubed. You have something cubed plus something cubed. The difference is basically the same thing. The only thing is, it's a difference of 2 things. So it's a cubed minus b cubed. Okay, so far really similar. And pretty similar process for taking these things apart, which is great. We love that. So with the sum of cubes, I'm going to give you the formula, and you're going to think it's crazy. I'll show you it works. I'm going to show you why it works. But the sum of cubes, it basically just falls apart to a plus b times the quantity of. We're going to get a squared plus ab plus, or no, go away, minus, go away. I swear I normally don't fiddle this much with technology. And then plus b squared. Okay, just to show that it works really quickly, if we were to FOIL this, I'm not going to do a true FOIL because it's a binomial times a trinomial. We got two critters over here, I got three of them over here, but basically you end up with a cubed minus, this is optional, you don't have to write this if you don't want to, this is just proof that works, minus a squared b plus ab squared plus a squared b. That was terrible. All right, where was I? Plus a squared b. I just did that multiplication minus ab squared plus b cubed. And the beautiful thing about this is so many things are going to cancel when we actually do this foiling out. You have a minus a squared b, you have a plus a squared b. If you have a plus ab squared, you have a minus ab squared. So those are gone. So we're back to where we started. So just to quickly show you, here's the thing, here's the formula, here's proof that it works. Yay. Now, same dealio over here. You might be like, wow, this is so weird, how are we going to memorize this? I'm going to show you how you memorize it in a sec. But it's basically going to be the same thing with just a couple modifications. And then once again, if I go about multiplying this all out, a cubed plus a squared b plus ab squared minus a squared b plus ab squared minus b cubed. And would you look at that? So there we go. It works. Now, the way you actually want to go about remembering these things is you want to use the SOAP system. And no, I'm not referring to the hand sanitizer that is strewn about every single building on campus. Not. So the SOAP is an acronym. What it stands for, yo, can you put that mask up on your nose? Is it stands for same, opposite, and then these two are actually a combo and come together. Always positive. If I didn't have a mask on, you guys would have seen my lips moving. I was literally mouthing like same, opposite, always positive as I was writing out these formulas. And let me show you how it works. Is you always start off with the general skeleton that's always the same. You always start off with A, B, then there's an A squared, there's an AB, and there's a B squared. Now, for the sum of squares, which is what we have on the left, okay, it was originally a cubed plus b cubed that we took apart, right? So the sign here, this is a plus. So for the first thing, you're going to use the same one. So you're going to use the plus. Then you're going to use the opposite one, which is a minus. And then you're going to follow up with always positive. And then for the difference of two cubes, basically the same thing. We have the same, basically, skeleton, a squared, ab, b squared, except because we have a cubed minus b cubed, we're going to take this sign here and we're going to use it. And we have same, opposite, always positive. So that's how you can remember how to do the sum and difference of cubes. So that was a lot. Questions about what this is, where it all comes from. After this, I'm literally going to do a whole bunch of problems with this and show you how it all works. But questions right now. Okay. So let's throw out a problem. And let's do 125 x cubed minus, and let's go with, and somebody made it to class, yay. Let's go with minus 8, another cube, yay. Now, if you're told to factor this critter, okay, using those formulas I just gave you guys, you know generically the skeleton this thing's supposed to follow. So we're actually going to use this thing that we just wrote out here. We're actually going to use just that. Okay, now the thing though is we need to actually plug in the parts. So I'm going to move this so I can actually hit the brush button. There we go. Okay, now actually plugging in the parts, so you need to spot what is A and what is B. That's the number one hurdle I see students struggle with. So let's talk about that. What is A, what is B? Because this right here, this is A cubed minus B cubed. Okay, that's a generic form. It's something cubed minus something cubed. Okay, I'm telling you that. Hopefully you can spot that on a problem. That is the difficulty with the problem. I'm going to show you how to work through that. But for right now, this is A cubed minus B cubed. So what can we do with that? We need to figure out what A is and what B is so we can plug them in. So what's the cube root of 125x cubed? Somebody saying it. 5x is your A. And then B is just going to be 2. Again, that's part of the reason we started doing roots and radicals last week, is so that way you guys can do cube root of 125x cubed, and you can actually pull that thing apart in order to get 5x. If you still have questions about that, talk to me about it. But for right now, let's just go with it. So now we're going to go ahead, we're going to plug these different parts into our formula that we have. So when we do that, we get A minus B, so we're going to get 5x minus 2. Times, we're going to get A squared, that's going to be 25x squared. Okay, plus AB, so we're going to multiply them. 5x times 2, we're going to get 10x. And then plus B squared, so 4. And that is your answer. Questions about that process? Not gonna lie, not having a water bottle to sip on, like while I wait for you guys to have questions, terrible. Is it bad that I'm eyeballing that cleaner fluid and I'm like, hydration. No questions? Comments? Concerns? All right, let's keep moving along. So another problem we could encounter is, oh, you know what? Let's do, so we have 128x cubed. And then let's do plus, 250. Okay, this is very much like a homework problem. This is actually the exact same format as one of your homework problems. In the sense that you look at and you're like, okay, I see the cubed, I see that, and I see it's plus another thing. I think generically this is supposed to be sum of cubes. Here's the problem. Go ahead, type into your calculator cube root of 250, and it won't like it. It'll be like, no, this is a decimal, this is disgusting. Same thing with 128. Reason being, your homework wants you to rip stuff out first. So that factoring we did at the beginning, where we were just ripping out, one thing or another, we're going to do that now. So, what do they both have in common? Well, they both look like even numbers to me. So let's rip out a 2. So if I rip a 2 out of both of these, 128 divided by 2, that's going to be 64. the x is going to be left alone. Anytime you divide an x term by a number, it always leaves the x alone. The x doesn't change. The number attached to it is what changes. Okay, plus, and then 250 becomes 125. Okay, now if you start typing these into your calculator, cube root of 64, cube root of 125, okay, now it's happy. So that's good. So we know that this is the sum of two cubes. Now we just need to go and actually attack the darn thing. Yay. So let's do it. So 64, that's going to be our a. So we have a cubed plus b cubed. So 64x cubed is not a. A is the cube root of that. So the cube root of 64x cubed. So 64 is 2 to the 6th. So divide that by 3, and then x cubed, and divide that by 3. And we're going to get 2 squared x. So we're going to get 4x. That's all right. Okay, b is much simpler, right? Because it's just a number. So you can just go ahead and check that into your calculator, or you can do it. Doesn't matter to me, but either way, b is going to be 5. 125 is 5 cubed. That's what that is. So now we're going to go ahead. We're going to use our formula. Now, again, if you're not so memorized on it, that's fine. Just generically remember it's same, opposite, always positive. Like as long as you get like where the A's and the B's are and you get the exponents, and then you just remember SOAP, you're going to be able to do it every time. Hence why I'm showing it to you now, so that way that can help you with the memorization process. Okay, so now we're going to go ahead. We're just going to plug our things in. And when we do that, we're going to go ahead. We're going to get 4x plus 5. 4x squared, square the number, square the x. 4 squared is 16. X squared is x squared. 16x squared minus 4x times 5. Multiply the numbers, we're going to get 20. So 20x. Oh, it's doing this again. Nope. And we're back. There we go. And then plus b squared, and that's going to be 25. Okay, now here's the thing though. This 2 that was sitting out front, still need to drag that for the ride. So our final answer, this is actually just a factored version of the 64x cubed plus 125. We need to bring the 2 along for the ride. Your final answer, and what you should actually be writing out / typing out if you're doing online homework, is 2 times all of this. So you're going to get 2 times 4x plus 5 times all of this. Okay, questions about that process? We'll leave the 2 out. When you're doing these kinds of problems, so the question was, throw the 2 in or no? The answer to that is no. If you're being asked to factor, the idea is I want everything ripped out as much as possible and just strung together with multiplication. That's the goal. Good question though. Anybody else? I'm trying to think whenever you would do any weird parentheses in my class. Definitely not here. If you want to put parentheses around the 2, that's fine, but just juxtaposing it, just putting it next to the 4x plus 5, I'm going to see that, yeah, you mean to multiply it. So, good question. Anybody else? Okay. Let's see, it's 8:40. I'm going to pull up your guys' homework, actually. Let's go ahead and do that. Because I thought I spotted one problem in there that I want to take a crack at. So, you know what? Let's call it a day as far as math. So this is the part where you can put your notebooks away.